section 10.6 is an introduction to functions. So the first thing we're going to talk about is what does a function actually mean? Okay, let's look at the definition here of a function. And it says that a function is a correspondence between a first set, which we call the domain. The domain is going to refer to the set of all the x values, and the second set, which we call the range, and the range is going to be the set of the y values. Okay? So the directions here say, let's find the domain and the range of the relation. If you recall, when we're writing points, we always write points like this, x comma y. So the first number refers to the x, the second number refers to the y. And let's see, the domain, I'm going to look here and I'm just going to look at, and I'm going to write down the set of my x values. So the first x value I have is 0. The next one is 3. The next one is -1. If you notice I have 3 again, I don't need to rewrite it again. Okay, it's already in that set, so we don't repeat them. All right. Now we have something called the range. The range is the set of the y values. So let's write the set of the y values. So we have 2, we have 3, we have 0, and we have -2. Okay. All right. Now, same thing on the next problem here. Let's write the domain. So again, the domain is just going to be the x values. -3, I have it again, I don't need to write it down. 4 and 7. And again, the range is just 5, 1, 6, and 0. Okay. Now, the next problems here say, which of the relations are also functions? Okay, the way I'm going to sort of explain this problem here, and I'll do it for another one too, I'm going to write my domain and my range in kind of like these two big ovals. So here's my domain, here's my range. The domain has the numbers 1, 2, 7, and 8. The range has the numbers 1, 3, 3's in there again, I don't need to repeat it, and 6, okay? And I'm going to just sort of do like how these points are paired. So when x is 1, y is also 1. So when x is 1, y is 1. When x is 2, y is 3. When x is 7, y is also 3. And when x is 8, y is 6. And what I want to do is I want to come back up here and I'm going to look at the definition of a function, okay? And it says it's a correspondence, okay, between the x values and the y values. And it says so that each member of the x values corresponds to exactly one member in the y value. So I want to look at this thing here. And the question I'm going to ask myself is, does everybody here get paired up with exactly one number over here? Okay. Well, 1 goes exactly to one number, it goes to 1. 2 goes exactly to one number, it goes to 3. 7 goes to exactly one number, it also goes to 3. And 8 goes to one number, it goes to 6. So when we think about like the domain and the range and sort of drawing it this way, what we say is that the people in the domain have to be faithful. They can't be cheating. And if you notice, nobody here cheats. 1 only goes to 1, 2 only goes to 3, 7 only goes to 3, 8 goes to 6. These people don't necessarily have to be faithful. And if you notice right now, the number 3 is cheating because it's hooking up both with 2 and 7. But as long as everybody here is being faithful, then we have what we call a function. So we're going to say this first one here is in fact a function. Okay. I'm going to do the same thing for this problem over here, okay? So I'm going to go ahead and do my domain and my range, okay? And I'm going to list my domain values, 0, 1, I already have 0, I don't need to put it again, and 7. Let's see, -2, 5, 3, and 7, okay? And we're going to see, okay, well, 0, corresponds to negative 2, 1 corresponds to 5, 0 also pairs up with 3, and 7 pairs up with 7. So again, if you notice, right now, 0 is not being faithful. 0 is hooking up with negative 2, and 0 is also hooking up with 3. So we would say this one here is not a function. So the people in the domain have to be faithful. The range numbers don't have to be faithful, just the domain. Now, if you want an easy way to figure out, okay, how can I do this without having to draw these circles all the time? I like doing the circles because it's visual and it helps me see what's going on. But the way you can figure out whether something is a function or not a function, just looking at the pairs, if you notice in the first set, the x values never repeated. And that's how I knew it was a function. And in the second one, the x values repeated with different y values, and that's how I know it's not a function. So if I come back to this one here, and I notice my x values, remember the x values are the first ones. The x values don't repeat, so that there is going to be a function. And in this one here, this x value is repeating with different y values. So this one here is not a function. Okay. All right. Okay, so the next part here says there's something called the vertical line test. The vertical line test just says if a vertical line hits a graph at more than one point, it's not a function. Okay. So remember, vertical lines are lines that go up and down. Well, if I draw a line going up and down, I only hit that graph at that one point. I can do that for every single point on this graph. And every time I draw a vertical line, I'm only going to hit the graph once. Therefore, this one here is a function. When I look at the second graph over here and I draw my vertical line, if you notice, we hit the graph twice. So this one here is not a function. Okay. Again, if I look at the same thing for my graphs A, B, C, and D, every time I draw a vertical line, I'm only hitting it one time. This is a function. In B, every time I draw a vertical line, I'm only going to hit my graph one time. This one here is a function. And in C, if I draw my line, again, I'm hitting the graph twice, so it's not a function. Okay. Sometimes I have people ask, well, what happens if you draw that vertical line and you only hit it one time? I'm going to say, well, you can do that, but then I can find at least one vertical line that's going to mess it up. So as long as I can find one vertical line that's going to hit it at more than one point, it's not a function. Okay. And the same thing for D. If I draw my vertical line and it happens to fall right on that other line, we're actually hitting it at every single point. So again, it is not a function. Okay. Okay. The next part here says, does the equation represent a function? Okay. The easy way to figure this out, if you look at the first two problems here, the first two problems, those equations also have the letter y. So those are in fact functions. Okay. This one does not have the letter y. So it's not a function. Okay. All right. So for the next part here, it says we're going to talk about this thing called function notation. And the way I read this part here, I'm going to put it in quotations, is y equals f of x. Okay, that's how I read that part. So when I see that little equation, I'm going to think of myself, y equals f of x. And it just says we use this notation to indicate that the equation is in fact a function. Okay, so it says given the function f of x is equal to 2x minus 1, write down the following, and then we're going to write it as an ordered pair. So really what I want us to do is do a little stare and compare here. I see that that's f of x equals 2x minus 1, and here I have f of 3. So the only difference between this and this is where I used to have the x, now we have the number 3. So we're simply going to substitute. Okay. So 2 times 3 is 6. 6 minus 1 is 5. Okay. So what that means is that f of 3 is equal to 5. And if I were to write that as an ordered pair, again, I want you to notice that where we had the letter x, we plugged in the number 3. So if I were to think about it as a pair, when x is 3, the y number is going to be 5. Okay. I'm going to do exactly the same thing here for this one, f of 0. I'm just going to come back to my function right there. 2 times 0 minus 1. Well, 2 times 0 is 0, and 0 minus 1 is negative 1. So again, that's just telling me that f of 0 is negative 1. But if it asks me to write it as an ordered pair, I'll write it as 0, comma, negative 1. Okay. So f of negative 2. Okay, f of negative 2, same thing. 2 times negative 2 minus 1. Well, 2 times negative 2 is negative 4. Negative 4 minus 1 is a negative 5. So again, that's telling me that f of negative 2 is equal to negative 5. And as a point, it would be negative 2, negative 5. Okay. All right, let's try the next one here. Find the values of the function. Write it as an ordered pair. Okay, so again, I got a new function. Here's my function, g of x equals x squared minus 2. And I'm going to write down what g of 5 is equal to. So we're going to say, okay, g of 5 equals 5 squared minus 2. Well, 5 squared is 25, minus 2 equals 23. So that's just telling me that g of 5 is equal to 23. And as an ordered pair, that's how I'd write it. Okay. Now we'll do the same thing for negative 5. So I'm going to put negative 5 in parentheses, minus 2. Now remember, negative 5 in parentheses squared means negative 5 times another negative 5. That's still a positive 25. Okay. And so now, oops, let me write my back over here. So now that's just telling me that g of negative 5, oops, there we go, equals 23. And again, as a pair, negative 5, comma, 23. Okay. All right. And so for the next one here, it says for the values of the function, write as an ordered pair. Okay. So let's go ahead and do the same thing. So h of 3 is going to be the absolute value of 3 minus 3. Okay. Well, 3 minus 3 is 0. And the absolute value of 0 is still 0. So h of 3 equals 0. And there it is as a point. Okay. H of 0 is the absolute value of 0 minus 3. 0 minus 3 is a negative 3. But remember, we're looking for the absolute value of negative 3. Remember, the absolute value just means how far is negative 3 from 0 on the number line. So if it helps you, here's my number line, here's 0, negative 1, negative 2, negative 3. How many spaces is it away? It's 3 spaces away. So that's now telling me that h of 0 is equal to 3. And again, finally, as a point, 0, comma 3. Okay, continuing here with 10.6, we're going to be finding what we call the domain of the function. So if you remember from earlier, we said the domain were the x values, right? Okay, so we're trying to figure out what numbers can we plug in there, okay? So what I want you to notice is that this particular problem here, we have a fraction. And when I think of a fraction really means that we're dividing. And if you remember, there's one number we can never divide by, and that number is 0. So what we're going to do is we're going to take the bottom part of our fraction, x plus 5, and we're going to set it equal to 0. And we're going to go ahead and solve that equation. And the number that I'm coming up with is x equals negative 5. So then what we're going to say for our domain is it's going to be all real numbers except for x is equal to negative 5, okay? And I'm going to do this anytime I have a problem that has a fraction, okay? So if I had, say, just another problem, f of x equals, I don't know, negative 2 over 3x minus 8, then I would do the same thing. I would just simply look at the bottom. 3x minus 8 equals 0. I would add 8 to both sides. 3x equals 8. I would divide both sides by 3, and I would get x equals 8/3. So then my domain would be all real numbers except x is equal to 8/3. Okay? Now, if you look at part B, I don't have a fraction in part B. If I don't have a fraction, my domain is simply all real numbers. Okay? We can plug in any number we want in that equation and we'll get an answer. Okay? Now, for the next part here, let's go ahead and do this problem. Okay, so for the next problem, we're going to find, again, the domain of the range, and we're going to do it by simply looking at the graph. Okay, so remember, domain is the x values. Well, there's my x-axis. I'm going to start cruising along my x-axis, going to the right, and I want you to notice the first number that we have for the x number, -3. And we're going to keep moving all the way along. The last number we have for the x-axis is +4. So that's just telling me that my domain are all the x numbers between -3 and +4, right? Because if I draw a vertical line going from here to here, my x numbers are all within that, little red box, right? Okay, same thing for the range. Now the range refers to the y values. I'm going to start from the bottom and go to the top. So I start coming up from the bottom. The first y number we hit at -1. Okay. We're going to keep going up. The last y number we hit, +5. So here's my range. All the y numbers between -1 and +5. Okay. So that's my domain, and that's my range. Okay. So now let's take a look at the next one. We're still going to do the domain first. I want you to notice that this graph here has these little arrows. What those little arrows mean is that that graph goes up forever and ever and ever. Okay? So I want you to think about it. I'm going to be cruising along my x-axis, coming in from the left, moving my way to the right. If you were to think, if I were to go up here, at some point, I would hit that graph. No matter how far to the left I started, at some point, if I kept going up, I'm going to hit my graph. Obviously, in the middle here, I would have to go down to hit my graph. But once I pass the number 5, if I keep going up, no matter how far to the right I go, because that graph goes up and up forever, I'm always going to hit my graph. So because that graph goes up and a little bit to the left and up and a little bit to the right forever, my domain is all real numbers, right? Okay. Now let me sort of clean that up a little bit. Okay, so let's erase. Let's make this prettier. Okay, here, there we go. Okay, good. Okay, so now let's talk about the range. Okay, remember the range are the y values. Again, I'm going to start from the bottom. The first y value we hit is at -2. But again, because that graph goes up, it goes up forever and ever and ever. So the y numbers are just simply going to be bigger than or equal to -2. Okay? All right. So for this next problem here, this is the last problem in 10.6. It says, use the graph to answer the following questions. Every time I teach this, I always tell my students, do yourself a favor and go ahead and label your graph. It's going to make it that much easier to see the numbers. Okay. So now, it says complete the ordered pair solution. When x is 0, what's y? Well, here's x is 0. If I want to hit my graph, I have to move down the number we hit, -1. Okay? So when x is 0, the y number is -1. All right, same thing here. When x is 3, if I want to hit my graph, again, I have to move down the y number we're hitting, -2. Okay. Now, look at the next part. The next part says f of 0. Remember, the number inside here refers to my x. Well, we just did that right there. So when x is 0, y is -1. We did the same thing here. When x is 3, the y number is -2. Okay. Now, the next two problems say, find the values of x so that f of x equals 0. You can think about it as if it's telling you, suppose y equals 0, what are the x numbers? Well, again, here's my y-axis. Here's y equals 0, right here in the middle. Oops, right there in the middle. If I want to hit my graph, if I move to the left, the x number we have is x equals -1. But if I also move to the right, I'm also coming up with x is equal to 5. So we actually have two numbers there. Okay. And for this last one here, it's the same thing. Y equals -3. So here's y equals -3. If I want to hit my graph, I have to move to the right, and the x number we have is x equals +2. And that is section 10.6.